Analytical constants: acid value, saponification value, ester value, iodine value, acetyl value, Richet Missel value. Let's start with analytical constant. Acid value, serum neutralization number. It is defined as the number of milligram potassium hydroxide required to completely neutralize free fatty acid present in 1 gram of fat or oil. Fatty acid, when react with aqueous sodium hydroxide or potassium hydroxide, it will form a salt of fatty acid. It is a measure of free fatty acid, that is FFA, present in the sample of fat or oil. Refined oil should be free from any free fatty acid, and oils in decomposition due to chemical bacterial contamination sometimes add free fatty acids. The acid value is determined by directly titrating the sample of oil or fat in an alcoholic medium against standard potassium hydroxide or sodium hydroxide solution. Here, potassium hydroxide is used as a titrate. Then first of all, dissolve about 10 gram of sample in 50 ml of mixture of equal volume of ethanol, 95% ethanol and ether. Then add phenolphthalein indicator and titrate it against 0.1 molar potassium hydroxide solution. Formula for acid value is 5.61 into N upon W, where N is bureau and W is sample weight. The acid value is a measure of amount of free fatty acid which have been liberated by hydrolysis from the glyceride due to the action of moisture, temperature, and/or electrolytic enzyme lipase. Oil with increased acid number are unsafe for human consumptions. Saponification number. Saponification value is the number of milligrams of potassium hydroxide required to saponify 1 gram of fat or oil. Saponification number is a measure of the average molecular weight of the fatty acid present. Molecular weight of fat is milligram potassium hydroxide upon saponification number of the fat. From above equation, higher the saponification number, lower its molecular weight. Principle: saponification is the process by which the fatty acid in the triglyceride or fat are hydrolyzed biochemically to give glycerol and potassium salt of the fatty. A known quantity of fat or oil is replaced with an excess amount of the alcoholic potassium hydroxide. After saponification, the remaining potassium hydroxide is estimated by titrating it against a standard acid. The value obtained is used for determination of saponification number of the fat or oil. The sample is titrated with 0.5 molar hydrochloric acid and take backtradic, which will be denoted by A in ml, then perform blank titrations, which will be denoted by D in ml, then calculate the saponification value by using the formula 28.05 bracket B minus A bracket close upon W, where B is reading which will be obtained after blank titration, means without taking sample, at A reading obtained by the titration process in which we use the sample. Next, significance. Saponification value also indicate the length of carbon chain of the acid present in that particular oil or fat. Higher the saponification value, greater is the percentage of the short chain acid present in the glyceride of the oil or fat. The magnitude of saponification value gives an idea about the average molecular weight of the fat or oil. Higher the molecular weight of the fat, the smaller is its saponification value. Iodine number, Siemens iodine number, is the number of grams of iodine that would add to carbon double bond carbon present in 100 grams of fat or oil. When fat reacts with iodine, then the carbon double bond carbon present in any compound, iodine will bind it to the same carbon which is bounded to another carbon by this double bonds, and it will form this iodinated compound. Principle: the oil or fat sample taken in carbon tetrachloride is titrated with a non-excess of iodine monochloride solution in glacial acetic acid. This is known as Wick solution. The excess of iodine monochloride is treated with potassium iodide. The liberated iodine estimated by titration with 0.1 m sodium thiosulfate solution using start solution as an indicator, and take the back reading which will be denoted by A, then perform a blank titration and take the reading which will be denoted by 2. Then calculate the iodine value by using the formula 1.269 bracket B minus A bracket close upon term. Next significance, the iodine value is a measure of amount of unsaturation, number of double bonds in a fat, greater number of carbon double bond carbon present in the compound, high is the iodine value and more is the unsaturation in lipids. Unsaturated lipids are more susceptible to density. Next, ester number. It is also known as ester value. It is the number of milligrams of potassium hydroxide which is required to saponify the ester present in 1 gram of substance. Formula for ester value is saponification value minus acid value. In this process, a glyceride is a fat react with sodium hydroxide solution, aqueous sodium hydroxide to give glycerol and soap. Methods. Weigh accurately about 2 grams of the sample and place it in a container. Then add 25 ml 0.5 ml potassium hydroxide and boil the solution under reflux consisting of water for 1 hour. Then add 20 ml of water and titrate the excess of alkali with 0.5 mol HCl using a 0.2 ml of Rockley indicator. Then repeat the operation without sample and take the blank readings. So in this process, we will take 2 readings, one with sample and second without samples. Then check the difference between the titrations, and this difference represents the alkali required to saponify the esters. Next significance, formula for determination of ester value, saponification value minus acid value. The ester value shows the amount alkali consumed in saponification of ester and is possibly identify and differentiate the fat with this value. Next, Richard-Meisel number. It is also known as Richard-Meisel value. It is defined as the ml of 0.1 normal potassium hydroxide required to completely neutralize the soluble volatile fatty acid distilled from 5 gram fat. RM number is useful in testing the purity of butter since it contains a good concentration of volatile fatty acid like butyric acid, caproic acid and caprylic acid. Butter has a RM value, Richard-Meisel value in the range 25 to 30, while it is less than 1 for most other edible oils. Thus, any adulteration of butter can be easily tested by this sensitive RM number. Next principle, fat is saponified by using glycerol alkali solution and acidified by sulfuric acid to liberate free fatty acid. The liberated fatty acid are then steam distilled with the steam volatile fatty acid are collected as a condensate. The cooled condensate of volatile fatty acid is filtered for separation of water soluble and water insoluble fatty acid. The water soluble fatty acid is then titrated with alkali to give the RM values, and water insoluble fatty acid is titrated to give the Polinsky value. Significance. It is a major water soluble steam volatile fatty acid, chiefly butyric acid and caproic acid present in oil. No other fat contains butyric acid glycerides, and therefore the Richard-Meisel value of the butter fat is higher than that of that for any other fat. These determinations have been used principally for the analysis of butter, etc. Acetyl number or acetyl value. It is the measure of milligram potassium hydroxide required to acetic acid which is liberated by hydrolysis of 1 gram of acetylated substance. Next, method to determine the acetyl value. First, boil the 10 gram of sample of oil or fat with 20 ml of acetic anhydride for 2 hours. Then add 600 ml water and boil for 30 minutes. Then separate it and wash the acetylated product. Then determine the saponification value of the acetylated substance, which is denoted by B in mLs, and then determine the saponification value of the substance, which is denoted by A in ml. Formula for acetyl value is 1335 brackets B minus A upon 1335 minus A, where A is saponification value of the substance and B is saponification value of acetylated substance. Significance of acetyl number. It is the measure of hydroxy acid in lipid, and increased number of acetyl value indicates more amount of free fatty acid.